This is AS1 January 09. A man pushes a wheelbarrow on level ground at a constant speed of 1.5 metres per second, as shown in figure 3.1. The wheelbarrow contains soil and the combined mass of the wheelbarrow and soil is 22 kilograms. The total frictional force acting is 12 newtons. State the force exerted by the man on the wheelbarrow. Explain your answer. And the whole point there is that you notice that they said constant speed. And therefore, if the total frictional force is 12 newtons, then the force exerted by the man on the wheelbarrow must also be 12 newtons. Give an explanation. The reason is because it's moving at a constant speed. Therefore, no acceleration. Therefore, no resultant force. And therefore, forces balance each other. And I would just state at the end that forward pushing force equals the frictional force. And so from the mark scheme, if you've mentioned no acceleration, you get a mark, and these two forces being equal to each other, then you also get a mark. Part B, the man now approaches a slope inclined at 5 degrees to the horizontal, as shown in figure 3.2. And you can see he's going to push the wheelbarrow up the slope. The man pushes a wheelbarrow up the slope, maintaining the same constant force that he applied in A. So that was the 12 newtons, if you remember. I'll just write that at the side. The frictional force has the same constant value of 12 newtons. Calculate the distance up the slope the wheelbarrow moves before it stops. Now, the first thing you have to do is calculate the acceleration of the body. So we have to draw a wee diagram here just to see the weight component. Let's see what I did with my ruler. Right, so if I draw a wee diagram, I'll draw it over here. It's a bit steeper than it should be, but right, there's the wheelbarrow and the man, and the weight component acts down the slope now. Acts parallel to or perpendicular to the bottom of the ground. There's your angle, which is 5 degrees, and then we need the weight component again at parallel to the slope, and this always seems to be the case. We always need the weight component parallel to the slope, and that weight component is W sine of 5 degrees. There's a 5 degrees in there. So this means the wheelbarrow is going to slow down. So the frictional force which acted against the man is going to be equal to this W sine 5. So we need to calculate an acceleration, because this is the frictional. This is the result. Well, yeah, this is an extra bit which is going to slow the frictional force down. So F equals ma. W is the sine of 5 is equal to the mass of the wheelbarrow was 22, see? Yeah, 22 kilograms. So it's 22 times 9.81 times A. Sorry, 22 just it is. And so therefore A is going to be equal to 22 by 9.81. That's the weight. The sine of 5 divided by 22. So it's just 9.581 times the sine of 5. And that gives you minus 0.87. So that's the deceleration. So the frictional force is the same constant value of 12. That means that the pushing force and the friction force are still the same, but there you've got this extra decelerating force due to the weight of the object on the slope, the component on the slope. And that's where we're getting the negative acceleration from. You then apply that to calculate distance. You then, because this is constant, you apply that to your equations of motion. And you've got A, and we're looking for S. So we got that U is equal to, V is equal to, 1.5. Because you're told this in the first part of the question, way back over the page. You know that it'll finally end up, that's U, you know that it will end up with a final velocity of 0 because it comes to rest. And then, what else do you know? You know v squared equals u squared plus 2as, and we're looking for s. So s is equal to v squared minus u squared over 2a, which is equal to 0 minus 1/2 squared over 2 by minus 0.87. And that comes out as 1.29 metres, or 1.3 to 2 decimal places. And last part of the question, calculate the total force the man must exert on the wheelbarrow and its contents to move it up the slope at the original constant speed of 1.5. The frictional force is constant at 12. Well, if that's the case, then he must apply this force here plus his 12 newtons he applied in the original to overcome the force of friction to move it at constant speed, because this the upward force must equal to the weight plus sine 5 times. Right, I'll just say that all again. There's a frictional force down, but he must apply an upward force there, I call it FR, an upward force to overcome these two. So we're saying that F is equal to the force he must apply. If he's to move at a constant speed, that must be equal to these two added. So that's FR plus W sine of 5. And that's equal to 12 plus 22 times 9.81 times the sine of 5, and that's equal to 12 plus 18.8, and that gives you 30.8 newtons. There's your final answer, 30.8 newtons.